All right, so if I remember correctly, where we were last time is looking at essentially these two type level functions. So we have this is just flip bind, and then the Kleisli composition, but flipped. So flip bind, flip Kleisli, and one of them behaves like regular old lazy. What's the right term here? Not lazy. It's, I forget the name of this. Anyway, it's basically just an application operator, but it always evaluates the right side first, and then the composition. Okay. Then we had this weird constraint thing that somebody, wow, we just jumped up to 4 viewers. Hello, everyone. Hope everyone's doing good. I'm just sort of getting warmed up and remembering where I was. I don't remember who it was, but somebody suggested that this was sort of a toy example. So we'll just keep going and see what we end up with. I think the next section here, 10.4, is we're going to talk about, well, I mean, I know what we're going to talk about. It's ad hoc polymorphism. But I think you can create maps of keys to values with arbitrary types. So we'll see what we can do there. Okay, so there's this itchy. Okay. We're gonna write an instance for this map on list for eval. I forget exactly what eval is. It's an open type family. What was the point? The point was, right, so we can embed functions into the type system. So second, for example. So I think what we're going to do is embed like some sort of map operations in the type system. I don't know if you noticed. Apparently not. So I think, let me refresh my my MooBot and see if things work. But I only see two things in chat right now. Maybe I should switch to a different bot. This one seems to be a little slow for whatever reason. I saw the one, but you guys are discording me. Yeah, I think my chat was broken. Could you guys try and send some messages right now? Hopefully it's okay now. I can see you now, new maid. Sorry if I was missing something. I don't know what happened. Did I not? Shouldn't it be? It should be. Well, what the hell? That's not what I wanted to do. Go back down here. I mean, you can go here, I guess. Hang on. Let me fix this title real quick. See if it works this time. Yeah, Bredor, I see you now. I saw your first message, but nothing after that. So I'm not sure what was going on. Let's see if this works this time. Yeah, okay, that seems to be working. So I think my chat's alive now. Yep, and I saw that programming guy as well as Active Fireball. So you missed basically nothing. Typewriter, I just started. So yeah, I start at 7:30 every time. And Bredor asked a question. First time I see type instance. So type instance comes from something. One of these. I don't remember which one it is though. Oh yeah, we have uptime, right. Oh, I appreciate the views. Yeah, we type families. That's I was thinking that, but I wasn't 100% sure. So we're basically creating instances of this open type family in the type system. So here's like a very simple example. So you can embed like the second function for a tuple into the type system. So that's how you get these, how you build these instances. So if you had a second AB, right, that's just a B. And you can do the same thing for like from maybe, and then I think we did list to maybe as well. I forget what. Yeah, this is called defunctionalization. So the term for this is defunctionalization. And now I think we're doing something with map, but I'm not. I mean, I don't know exactly what yet. What's this error? Oh, probably because this isn't complete. So we'll keep going. So we're gonna write, I don't know, something for map. Let's see. So f empty list equals empty list. Oh yeah, okay. It was complaining at this line, so we're okay. Can everyone read this okay? Is this big enough? I can make it bigger. I'm gonna make it a tiny bit bigger, but I don't know how big it needs to be. I just want to make sure everyone can read it. It drives me insane to go into other people's streams and not be able to read what they're typing. Oh, I see. I just realized that we're implementing the function map, not a map, right? Like key value pair. I just realized that. I don't know why it took me that long considering this type signature, but anyway, sorry. So now I know that what we're doing, so I can probably figure it out without much hassle. So we'll have, in theory, and then we have, yeah, a eval fa app fas. Oh, I think I need another eval. Is that right? Eval fa eval map. Yeah, cool. I wanted to try to do it without looking. Is okay. Is chat dead again? I'm very concerned. No, it seems fine. I think it'll be okay. I do like this bot quite a bit, so I really don't want to get rid of it. Yeah, it seems fine. Okay, perfect. Okay, so let's continue. So there's map. So then we can write, we can also write one for maybe. So let's do that. Map f maybe a, I guess. This probably needs to be, no, that's not what I'm doing. I want to put the nothing first. Eval map f Oh, side note, if anyone's interested, defunctionalization is an old thing from functional programming in general. The core idea is replacing applications of functions with a single function that takes a value signifying what function is being called and with what arguments. Interesting. Thank you, TypedRat. Very useful information. Why is this broken? This seems like it should be right. Well, okay, we get rid of this. So is this supposed to be like this? I see. Right. So the eval is we got to stick if we only need to eval if we're really like evaluating something. So we have to evaluate well, f nothing wouldn't make any sense, right? Because f would take an a, not a maybe, right? Because we're implementing basically f map at the type level. So we're not really evaluating anything, so we don't need eval there at all. Here we need eval to get us the value of f apply, or sorry, x. No, I said it right the first time. F applied to x, and then we'll wrap that in a just. So it looks very simple. Oh, that's okay. No worries. No worries. I know, you know, we're all kind of thinking out loud. Maybe not TypedRat. If I remember correctly, you know, she's really good at this. We're not, so we're learning. I believe it's she. If I'm wrong, I apologize. Please let me know or correct me. Okay. So either we can do the same thing. I think I can figure this one out as well. Eval map f left error is just going to be okay. And then we'll try and wonderful. It's been a week and I'm very forgetful, so I tried to use gender neutral terms when I don't know, but I thought I knew. So I went for it. Luckily I was right. Okay, so oh, one thing I should mention, by the way, just so everyone knows, I don't think it's gonna make, oh, that's not what I wanted to do, but I upgraded Haskell IDE engine, so we're running now the latest nightly version. I think that's the right one. So we'll see if we find any bugs, but I doubt we will. They move some stuff around in Haskell IDE engine, but it compiles just the same, so it should be fine. And it didn't require me to rebuild like Cabal and everything else, so that's pretty convenient. All right, so let's try this. So, kind, simplify, eval, map, second, just, so the, here, oh no, we can do that here, I guess, I think. I think I can do it here. So info either And then we can do, so hang on. How do I do that here? I want to parameterize this with either. Can't I do that? Bagel Crush. Thank you so much for following. This is gonna be harder than just like going to look this up in Google, but I'm pretty sure that you can't apply F to E because the type is A to B. So the type is, you know, let's just go look. Just so we're for sure. Here it is. I'll look at the functor. Yeah, so right, remember that this F here has a type of whatever Y is to something else, Z, let's say. It does not have the same type as this X. So you can't apply F to E or X in this case because they're not the right type. So if you have an error, right, you just, it's like nothing, right? If you had a maybe, you just carry nothing through. In this case, you carry your lefts through, and then I think, yeah. Does that make sense? Hopefully that makes sense. But the types are wrong, essentially. Okay, so let me see if I can use this thing, and we'll try and read it. I know, if I remember correctly, we have to do something with like FCF dot. I just don't remember exactly what it is. Okay, so map second. Oh, I'm missing some stuff here. And this needs this. Yep, I need to turn on data kinds. And then there we go. Okay. So we're evaluating fmap. So it's basically mapping the functions. We're literally writing this. Right, that's what we're writing, just at the type level. Okay. Cool. I think it's cool. We can also embed this as a list. So you could say, so here, I think this is right. Yep. So you could do something like this, where you have map second on a list. So I just put two tuples in the list, so it should give me 2 and 4, because that's second, which again is very simply so typed rat, can you correct me if I'm wrong? So this evaluation is at the, would you say at the term level? Is that the right term? Term level versus type level? I think that's the right terminology. Perfect. Wonderful. I feel like we're learning. That's good. Okay, so we're gonna write a promoted functor instance for tuples next, and that's the next exercise. So let's do that real quick. I think we can do that pretty easily. So we're gonna have one, two, x, y equals. So we're gonna create this and stick x into it. Then we need to eval fx. And that's pretty easy exercise, but it's an exercise nonetheless. 10.4-I. Okay, so let me just double check this real quick, and then we will move on. But I'm pretty sure that's correct. I can't imagine that this is hard. Yep, this is right. The only thing that he changes is the names, but again, that's alpha equivalence. Alpha equivalence? Again, still working on terminology, but I think it's alpha equivalence, right? If I just name this A, it's the exact same thing as X. So look at me, I'm on a roll. Finger guns. Okay, so this technique of ad hoc polymorphism generalizes in an obvious way, allowing us to implement the semigroup operation mappend or mappend, depending on, you know, how you want to say it. So let's start writing that. Type instance. So how's everybody doing today? There's like 8 people. How are you guys all doing? Tell me about your days. Tell me what Haskell projects you're working on. I want to know interesting things. Especially after I'm just copying stuff from the book, so. uh Can't type. Okay. So we just tuple the constraints up, apparently? Well, I guess that makes sense for a constraint, right? Because a list of constraints is just them tupled up. So that makes sense. If I remember correctly, I have read this before, so I think what we're going to do is we're going to write the memty instance as well, but the memty instance is a lot trickier than the append instance, because there's no way to know. I forget how it works, but something like there's no way to know what the type of memty is or to how to get it or something. I don't remember exactly how this works. Okay, so for this one, we just need to eval this, I guess. Um, Okay, well, this doesn't work. Do I need to define? Append question mark? I'm not sure what that means. Use the append function? I feel like something's wrong here, but I don't know what it is because um oh, it says so. Just for reference, I'm reading a little ahead. It says it's unclear how this approach can be used to implement empty. Type families are not allowed to discriminate on the return type. That's so we'll get into that here in a second, but I'm unsure what's going on here. So let's quickly just reload and make sure. No, it still thinks. So how do we get the type constructor for this? Can we get it from? Yeah, everything looks right. Not sure what to do here. Makes it seem like this should compile. Clearly doesn't. Can I? Oh, I wonder if I have to write this function. Can I write this function? Probably. Yeah, that's what I'm wondering. But it wouldn't be plus plus anymore. It would be like some name m. Well, not m append, but something else. I guess this function would be called like I mean, this is the append function, right? So we could just call it append. Oh, that's your question. I get it. Sorry. Now I get it. So we need to, let's just, I guess we can try and write it. So I understand your question mark now. So we'll take a list of a. Yeah, I get it now. No, 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 no. I need to explicitly pull this apart, right? I think so. Yeah, it probably. Well, maybe it can't be implemented with two only because we're at the type level. I'm not 100% sure. Let me write it this way and we'll try and simplify. Um, oh no, you can implement Menti, but there's a trick you have to play to make it the case. You can't just like it's not trivial. That I think that's the point. Is it's slightly more complicated than this. Also, time to take a drink, but I don't have my water here, so let me grab my water and I will be right back. Okay, I am back. So, grab a drink. Perfect. Um, I don't know. Yes? Expected a type. Oh, these aren't. These don't need these. Um, that's why. There you go. Ooh, excuse me. Okay, so we'll come back to Bredor's question here in a second. What's going wrong with this one? Expected a constraint. Oh, apparently I just need to get rid of this. Yeah, sometimes that's really confusing to me. Like, um, let's look at the error for this. Maybe it will help make sense. So what is it? GHCID C nope stack REPL. So okay, so it says expected a constraint but got a kind. So that's how you know it needs a value, I guess. So you need to generate a value of A, B. I think that makes sense, but I'm not sure I would have come up with that right away in my head. That is. Okay, I suppose we should see if this works because I legitimately don't know. And then, okay, so can we implement this with two? So the first one can be empty, right? Why do I no, that's a side effect of the syntax hack for how constraint union is written. Didn't I do that in here? Oh, I wasn't using collapse, right? So this is just interesting. It's constraint. So where is that defined though? That's not in here, right? Or is it in here? I'm not using collapse, so I just want to make sure I didn't write this, and that's why I'm confused. But I don't think I wrote that. So okay, thank you. But okay, so but this is like a okay, this is a logical and for a constraint, uh, similar to like this, right? That's what you mean by a logical and. So when you write like f, um, why am I blanking? Or something, right? I can't type right now. Whatever. Da, 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 da. So when I type this, this is the piece that's the logical and, yes? So that's what you're talking about, I think. Got it. Okay, wonderful. Thank you. So I'm gonna write a note in here because I think this is a little strange. So okay, so the right? So the constraint is actually a logical and. Above we can't use tick because that represents a tuple. So they're actually just different things. And one of them is sort of a compiler syntactical thing. Um, logical and is a compiler quirk, or it's a syntax quirk. Syntactical quirk. Is that spelled right? I think so. Okay, so and then so we think we can get away with oh, it's okay. You don't feel dumb. Um yeah, I don't want anyone to feel dumb. Absolutely not. That's hilarious. Okay, so can we actually reduce this? I mean, if you give append, I don't think we can reduce this, right? I don't think we need that. Does it matter what's on the right? I think you mean... Can you write append? I think you have to, but I'm not sure. I think you mean here, so let's try that. I thought you had to deconstruct, but maybe you don't. Let's see. It seems to compile. Oh, neat. We're gonna show some Agda code apparently. Can I like merge these two? Should have just opened it here, but it didn't really let me. Oh, I guess that's right. If YS is just an empty list, then you just get an empty list. Yeah, so yeah, I guess this is correct. It doesn't, for whatever reason, my brain never comes up with those. Yeah. So the other thing I wasn't aware of is that one can just you don't need to deconstruct the list. I thought you needed to. So let me so we only need... Okay, so I think this is right. What's up, Madasaur75? I'll just call you Madasaur. And how are you? Are you Haskeller? New to Haskell? Friend of Haskell? Just interested? Tell me about you, friend. And while it doesn't matter at the type level so much, that's really important at the value level because the right list could be huge or even infinite. Oh, I see. Oh, sure. So we are, this whole channel, actually, is all about learning Haskell, which I don't know how much you know. I assume you're interested in programming languages to some extent because you're here. But yeah, I'm just interested in learning Haskell. So we're basically taking textbooks. So here's the textbook we're working on now. It's called Thinking with Types. And we're basically just working through it and doing the exercises. So on Sundays, we do this book. On Tuesdays, we're working on Book of Monads, which I can go grab if you're interested in. And then on Thursdays, we just work through problems on exorcism, if you're aware of that. So that's what we're doing. So right now, we are working on chapter 10, which is all about first-class families. So essentially what we're trying to do is take functions at the value level or term level and embed them in the type system. So as an example, I don't know how familiar you are with Haskell, so I'm going to pick an easy one to start. And if you want me to keep going, we can keep going. So here's a function. Let me also do this real quick. So hopefully you can read this thing on the bottom. So there's a function called second, which basically, given a tuple, picks out the second value of the tuple. So it only works on two tuples, not anything more, and it'll just pick out this two, okay? So it turns out that you can embed these at the type level using what's called defunctionalization. And if you had a data type that represented a tuple to some expression for b. So this is the extra bit. So if we look at the type of second, you'll see it kind of looks similar, a b to b, but you use this x thing to embed this. I'm not sure what the right terminology is here, but you use this x to give you what you need. Yeah, the code is always on GitHub. I think it's just code. Yep. Code is always available. If I'm allowed to give it out, there are cases where I'm not. Anyway, so you have this function that looks like this, and then you can embed it at the type level in this way. So you can say eval, which is this type, what's called an open type family, second a, b, b. All right, so that's how you embed second at the type level. And then there's a bunch of functions that we're embedding at the type level, basically. So this whole book is all about type level programming in Haskell. So that's what we're doing. Does that help? Is that interesting? I don't know. You know, it really depends on your experience with Haskell. I really don't. You know, I don't know. Okay. Onward. So I suppose I should write this down because we might want to suggest this change to Sandy. Probably. It might already be fixed. Let's go check real quick. So this book is actually just a GitHub or repository, if I remember correctly. ISO vector. So yep. So either I just missed it. I don't think I missed it though. But he actually just ends up defining this data type. So we can actually define it like this, which is interesting. I didn't realize that you could. So that actually looks a lot cooler. Apparently you can't use it infix though, but that's fine. So do we care? Do we like this as append, or would we rather this be a prefix plus plus? I don't think it really matters, but I think when we look at this code later, it'll be weird not to see it as plus plus. That's the only I can think of. So let's see if we can quickly rename it. Oh, yeah, it looks more Haskell-y, especially, but apparently it doesn't like that. So we need to. So there's no mapend here, so we can easily just s it. And then do you need it like this, or can we actually stick it in here now? Okay, so it seems to work. And then we should make sure that, okay, it's actually coming from what we think. So that's sweet. Cool. So you don't even need to prefix it. So in this code, you'll see there's a prefix for plus plus, but you don't even need it. Oh, wait, that's in the actual evaluation. That's here. So, okay, that's the difference. That's cool. Okay, so I didn't realize we were going to be able to use this infix. So that does look a ton better. not only is it cooler, it just looks better. It looks like Haskell. Okay. Anyway, hopefully we didn't lose Matazor. I'm not sure if this is interesting or not, but it's kind of weird stuff. XK. I don't know why we use K so often. Does there anyone know the reason for that? I mean, if there is a reason, could just be a preference. Okay, so type families are not allowed to discriminate on the return type. We can cheat this restriction by muddying up the interface a little and making the type application explicit. We give the kind signature of mempty as follows. So there's our kind signature. The understanding here is that given any type of any monoidal kind K, mempty will give back the monoidal identity for that kind. This can be done by matching on a rigid type signature, as in the following instances. Excuse me. So, whoops. So I think that. Oh, sure. That makes sense. That makes sense. K is short for kind. I like it. I may have asked you this already, but have you written code like this before? You said you may. Maybe I remember that you were working on something that is doing type level, and that's why you tuned in. I think that's what was happening. Yeah, that's what I thought. I'm very glad that you are here and helping us through this. It's really, really nice. Oh, I probably need to put this in parentheses, huh? Constraint. So wait, why is this hard? I'm confused. This doesn't look that tricky to me. Oh, wait. Why is this complaining? Uh, it's also oh, okay. I see. This is unnecessary. Hang on. I'm trying to understand what's going on here. Let me. Seems fine. I'm not sure what it was complaining about. Sometimes that happens. Why do I always do this? I should just copy link. Okay. What? I don't. So we can just write this. Uh. I do need it here though, right? I think maybe he was just trying to keep the notation similar, but again, this could be fixed in the in here. Let's see. So I don't know. Anyway, yeah, that looks really nice actually. I guess I don't see, you can't do constraint without this, right? Like, you would need to specify anything that's like not a list, like a tuple you could do pretty easily. Oh wait, I can? How do I do it with constraint? Do I just, I mean, if it knows what the return type is, it should just know what this is, yes? So that works. Oh. Okay. So let me actually, let's go back to where we were. Shift U. So oh, exp. Oh, I probably need a K. Yeah. Okay, that makes sense. We were just missing one kind, right? Because we have to apply it to something. Oh, this was just in here. I see. Oh, so I don't even need, I see what you're saying. I don't even need this K. Okay. So, okay, so let's do this. Let's do something different. Hang on. So this is sort of like, let's make this a K. So this is one way to embed. I see. Oops. Oh wait, I can't have that one. This needs a prime though, and that needs a prime. Wait, what's wrong? This seems right. Or did I? Oh, okay, okay. So, but we're okay. I think we're okay. Okay, so what do we want to say about this? I don't know what we want to say about it. So, do you mind it? I think I understand how it works, but I'm just trying to decide what's the best way to write this, or like to write the, why is this better than another? Maybe I don't understand why it works, but that's probably okay. So I think, let me think here. So polykinded type families take the kind of the variables in their arguments as implicit arguments, so you can match on kinds. I see. Do I see? I think so. Okay. So we're saying this mempty has kind exp of empty tuple, I guess, of void. I think we pronounce this void. So if we match this kind, just give us back unit. Void is different. Thank you. So if we find this kind, just give us back the promoted unit. If we find this kind, give us just back a empty I don't know what the right term is there. An empty constraint list, I suppose. Or constraint list. I mean, empty constraint, sure, that will work. I'm trying to be better about terminology, so being oh, okay, that's a good way to put it. It's like no constraint at all, or trivially true. I like that. Okay, and then this one would just get back empty list. Okay, so this version uses the fact that GHC polykinded type families can pattern match on kinds? Eval is really oh, okay. So I'm really matching on the first invisible implicit argument. So there's an implicit argument here of E, the A in your text. So we're pattern matching on an implicit E. Implicit A. In my text or in your text? Just making sure. Okay. So there's an implicit value. Yeah. Would it help? I don't know if it's helping. So essentially, in each case, this I'm confused with this implicit stuff, I guess. I think I'm more confused now, unfortunately. I'll wait to maybe a type wrap will help us out. So in this moment that we're waiting, just a second, let me point something out. So you can get this book, so I don't have to show it at the end. You can get this book from here. It's really easy to get if you're interested in getting it. I think it's a pretty fun book. It's very hard. We're gonna get into some pretty hard stuff here in a little bit. I also realized that I just skipped my drink thing, so let me do that. Water's delicious, and I spilled it on me. Okay. So actually, we are done with this chapter. Oh, I also should mention that I don't get anything if you buy that book. So I don't want anything, but I was asked to show this. So anyway, we'll finish this. So need to plug this in. Oh, also, since there's 10 people watching, can we take a little poll? If you're willing to answer said poll, I don't have a poll thing set up, so I'll just informally ask. Music, yes or no? Do you feel like the stream is lacking because there isn't music? I actually don't care, but the channel is bigger than it was when we first started, so nobody answers. I'm going to say the default value is no because I won't listen to it, I suppose. And also, it seems really hard to get music. It sounds a little tricky, so let's ignore it for now, and we'll just I'll write. Actually, let me write something in here to say that this is it's a little tricky, and okay, so let's say the below code uses. I do like some hip hop. So the below code uses a is it a trick? Is it fair to call it a trick, or should I call it like I'm gonna call it a trick in quotes. Okay, so the below code uses a feature of the compiler to reduce what do we think about that? I think it's reasonable. I think this is readable. Like, I think I mean, I understand what the end goal is. How it's done, like the implementation detail, that part's the tricky part. Well, I don't have 5 years, so, well, I guess it probably doesn't take 5 years to read a PhD thesis, although it might take me, I don't know, mine's pretty rough. Ow. Okay, so we're actually done with chapter 10. Do 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 do. So now we're on. I guess there's a newer LTS. We were using 1330, but now there's 14.0. So we just gotta keep that in mind. What did I just make? Chapter 11. So I gotta update my title. So this is called Extensible Data. Okay, so readme extensible data, and we need to change our stack version to 20G 1330. Wonderful. Okay, so I think, oh yeah, and I gotta fix this crap. Nope, wrong button. That's not how I should do this, but oh well. Edwin's Roar. Thank you so much for following me. Really appreciate that. Tell me about you if you want. You don't have to, obviously. What's your experience with Haskell? Are you interested in it? Whatever you want to tell me. I really appreciate the follow, though. I think actually with that one, did we get to 75? I think that's 75 followers, which is new. Yeah, you know what? Somebody, I think it was Newmade, mentioned that as well, that we should just write our own template for a stack, so we don't have to do this, rewrite this as much. But to be fair, I don't use Stack more than just creating a project and building and running, so I'm not even that familiar with Stack, because I don't really use it for any projects, right? We're just using it for this. So at some point, I'd like to go back and learn more about Stack. And also, apparently, Cabal version 3 just came out, which I guess does some interesting stuff for you. So we might want to like compare and contrast Stack and Cabal for our new projects or something. So yeah, a major Cabal contributor. Wonderful. So I think that at some point we definitely need to dive into Stack and Cabal a little more carefully and decide which one we want to use. I know that there are kind of not flame wars, but like some contention between the two at times, from what I can tell. But I don't have any experience with that, nor do I care about things like that. I would like to try them both and see which one I like better. That's how I feel about these things. So Edwin's Roar. No experience with Haskell, but I know F# and am learning Scala. Just appreciate functional programming streams. Great. Well, we are explicitly a Haskell stream, so yeah, we're gonna do Haskell forever, I suppose. So Breder was just saying, like, to fill in extra information. Yeah, I could do that as well. I guess I just need to put that in some like global stack file, right? We could add that stuff, but I'm not putting any of this on GitHub, so I don't feel too concerned about that kind of stuff. But it would save myself, I guess, a little time. I think I would rather just have my own template, which I think Newmade showed me how to do at one point, and then I just kind of stopped doing it. Also, yeah, I'm sort of talking a lot right now. So Edwin's Roar, I've seen some F sharp, looks cool. Scala, I tried Scala. I just don't think it's for me. I think maybe when I get further down the road with Haskell, at some point I'm probably gonna have to pick up Scala again. But we're probably not gonna do that kind of stuff on stream. So we're just gonna do Haskell on stream and learn as much as we can and go as deep as we can. So that's a big thing about this stream is like I want to go as deep as possible. So folks like Typed Rat are gonna help me do that, I think. I was jumping around a few topics there. I got a lot on my brain at the moment. Okay, so how much time do we have? We got a half hour. So I think what I'll do is essentially motivate this chapter, and then there's no way we're gonna finish this chapter, but that's fine. Okay, so yeah. That's okay. I think it looks wild. Like when I looked at the code in here, it looked pretty crazy. Anyway, the point is we want to be able to essentially emulate Python. Okay, so we're gonna load up and write a tiny bit of Python. I promise it won't last very long, and it should be pretty painless. So we want to be able to do something like this. Foo bar true. Okay, so in Python you can write this kind of stuff, and you can even add stuff to this. Sure. Right, and you can overwrite. Well, let's just so you can just like add stuff and change this kind of stuff, and it's super easy. And so what we're going to do is apparently write the Haskell version of Python records using extensible data. So Edwin's Roar says, yeah, I'm not a huge fan of Scala either so far, but I want to learn a JVM language that doesn't drive me crazy. That's fair enough. Yeah, I've seen some Clojure. Also, check out like Kotlin. Kotlin looks like a pretty lightweight language in the that looks pretty useful as well. I've seen some Kotlin. I've not seen any Clojure, but the basic Kotlin, unless you have some specific reason for learning Scala. Yeah, it's kind of like a weird, sort of a strange intermediate language. Yeah, it depends what you're trying to accomplish, right? I mean, there's a million programming languages, so it's hard to pick one. So yeah, we're basically trying to embed this into Haskell. I gotta close this door. Hang on. Okay. Hopefully that's a little bit better. My girlfriend's having like a Skype date with a friend, and she's getting loud. So I'm having a hard time focusing. Yeah, I've not looked at any Clojure, but I've heard good things. Also, Oren, I don't understand your question, but I will say good evening. How are you? Coming late. That's the part I don't understand. You mean, why is it a question? Okay. So, yeah, Python isn't a typed language, although there was an interesting comment in this book about, I think it was this book. Oh, yes, you are. Yeah, okay, I understand. Yeah, stream started at 7:30, so an hour and a half ago. Yeah. We always start at the same time. We try to, anyway. I think I've been late before, but I try not to be. Oh, yeah. So what I was trying to think of, the comment in this, I think it was from this book, is that non-typed languages, such as, well, I mean, Python technically has some types, but what's the comment? I forget. Untyped languages are actually strongly typed languages with only one type. I believe that is the comment, something like that. I thought that was a really interesting way to think about that. So anyway, if you're Ada as well, there's a lot. More than I was expecting. Okay, let's keep going. So in this chapter, we're going to discuss how to build this sort of extensible record type. As its dual, we will also investigate generalizing the either type to support an arbitrary number of potential types. These types are a good and instructive use of type-level programming. Okay, so we saw that all of custom Haskell data types can be built as sum of products, sums corresponding to either AB and products corresponding to the pair type. Pair type is pair type. However, just because we can show an isomorphism between a type and this sum of products doesn't mean such an encoding is efficient. Because both either and I'm not sure what to call this operator, the tuple operator, because both those operators are binary operators, using them for arbitrarily large representations will require lots of extra constructors. In the best case, our representation will be a balanced binary tree of the form either. Here, let's do this. Okay. Interesting. So apparently closure is pretty helpful. Okay, so apparently Ada doesn't support this type level stuff, but closure is seemingly more productive than Scala. That's the soft take in chat right now. It's interesting. I've not looked at closure or Ada, so I have nothing to contribute to this conversation. So if you're interested, check out chat. So, okay, I forget where I was, so hang on. Okay, so using these binary operators to build arbitrarily large representations will require a lot of extra constructors, and our best case can be represented this way, so like a bunch of ethers. This corresponds to an overhead of big O log n constructors. In the worst case, it degrades into a linked list, and we pay for big O of n constructors. It seems, however, like we should be able to describe a sum of any number of possibilities in big O of 1 space, since it only ever contains one thing. Likewise, that we can describe a product in big O of n space rather than big O n plus log n balanced binary tree or big O 2n linked list. The trick, I think we're missing a word here. The trick to building extensible sum and product types is to use the type system to encode the extra information. Anything we do at the type level is free at runtime. Because open sums have fewer moving pieces, we will work through them first and use our lessons to help build open products. Okay, so the last thing I remember of this is that the code was really, really hard for me to understand. So hopefully, while we work through it, it's going to make a lot of sense. Although, I'm a little concerned about starting this now, only because we have a half hour. So, what should we do? Because there's no way I'm going to finish this code in a half hour. And we can just get going. It'll be fine. My girlfriend's still talking, so we can go a little late probably. Straight kinds. We can play Space Invaders. Why does it do that? I don't know why it's doing that. And then it doesn't. Data kinds, flexible contexts, flexible instances, gadgets. Oh, you know what? Typed rat. So one thing that we came across, and it always seemed wrong to me, is that this is pronounced gad-its, not gad-ts. Why is that? Or is that the right pronunciation? The pronunciation you're using? It was very confusing to me. Yes. And it was pronounced, in the book, it literally writes gad-its. Oh, you pronounce it, you say it as an acronym. GADTs. Yeah. Okay. Cool. So everyone is okay with me calling them GADTs instead of GADITs because I don't like that. It just sounds wrong. I don't know why. GADTs. Hopefully everyone's on board. I think I'm going to use that. Okay. That's what's written in here. I didn't make that up. Just for reference. Everyone can blame Sandy. Don't blame Sandy. His book is fantastic and we should be very nice to him. Scoped type variables, type applications, type operators, and undecidable instances. Okay, so that's all of the language extensions that we need apparently. Then we need some imports. I think we need to ghc dot typelets hiding type. I have no idea what that means. And then this will require, oh, if anyone's not seen NeoVim plus Haskell IDE engine, here's like one of the cool things you can do. So wait, what? That's clearly not correct. Okay, well, I lied. It doesn't work. I don't know how we get that to work, but I think that this is a package. Oops. So package YAML 23G. Oh, first class families. Is this different? I thought this was first class fam. Okay, good. And then I don't know how. Hopefully this doesn't take very long to build. Doesn't look like it. Wonderful. Drink time. Maybe, but it has worked for things. Well, maybe it hasn't. I'm not 100% sure about that, Lumi. I'm not sure if it's worked every single time or not. It's worked for most of the things, but most of those things we've already used, so that's an interesting point. Everyone should have a drink of water or something. It doesn't really matter, I suppose. I'm gonna drink water, but I do have some wine that I need to drink tonight because I don't want it to go bad. Maybe I should go get that. All right. So now that we have all this stuff, we can start writing this open sum. Unsafe open sum. FT FTS. Okay, so this is a GADT, and we have it contains one type constructor, which takes an integer and an f of t. No, f of t. So is this supposed to be like a key? T. What is this T? This is the only thing I'm a little confused about. Okay, anyway, I'm going to keep reading and hopefully this will become more clear. Somebody might tell me what it is by the time I get there. Okay, so GADT, it has two parameters, f of kind k2 type and ts of kind list k. We call f an index type, which means it provides a type when given a k. We'll talk more about these parameters in a minute. The data constructor unsafe open sum at 2, well, this one, is thus named because, well, it's unsafe. We'll later provide tools for constructing open sums safely, but building one via the data constructor isn't guaranteed to maintain our invariance. The common pattern in type-level programming to label raw data constructors as unsafe and write smart constructors that enforce the safety. Where is it looking at now? 3. So here, we're going to explain that part next because I think this is the part that I don't understand. We see that open sum is a container of f of t where t has kind k. Because t isn't mentioned in the return type of our constructor, it is existential. Once t enters an open sum, it can never be recovered. Knowledge of what t is lost forever. Interesting. I remember a little bit about the existential types, but I think maybe using them is going to help help us understand them. If I remember correctly, we used existential types to... what did we do with them? I can't remember what we used them for. It had something to do with making sure that two types weren't the same, but I don't remember why we did it. I'd have to go back and find that code. Actually, I might be able to figure it out real quick. Is there a index? Because I just need to index existential type, basically. I'm sure that was the first time we talked about it. Wait a second. Oh, that's the glossary. Oh, there's no index. Unfortunate. Okay. Anyway, I can look it up later, but We used these before for some reason that I don't remember offhand. Returning to our parameters, we assign the semantics that the existential T must be one of the elements of TS. If TS Okay, so T is existentially an int, bool, or string if TS is this, but we don't know which one. You might be you might be wondering about the value of the f parameter. Its presence allows us to add a common shape to all of the members of TS. For example, open sum. Hang on. String int bool is capable of storing So users who just want to store regular types with no additional structure should let f be identity. Sure. So that's kind of interesting. So now, so are these? I guess I don't understand what this is yet. We'll get there. The OpenSum data constructor also stores an int, which we'll use later as a tag to remember what type the existential variable t had. It will be used as an index into TS. For example, if we were storing the number 2 in TS, here, hang on. Type T had, for example, if T is 2, oh, sorry. No, stop that. As type C. Okay. Does this make sense? Is everyone okay? So this F just lets us put T inside of a container so that we can store more, essentially use more complex types. Or we can feed unsave OpenSum more complex types. I suppose we'll see that here in a little bit. Okay, so now we can use a first class type family can be used to find T in TS. So type find lm key, oops. Okay. All right. So this operates like a like dollar sign. So let's or function application. Um, tie equal. I don't remember. We used this before, but I don't remember exactly what it means. So let's pop open. Right. That's just our first class type family to figure out if things are equal or not. Uh, Mario who writes. Thank you so much for following. Um, how are you? What is your experience with Haskell? If you feel like sharing, um, have you ever used Haskell? Are you interested in it? Um, let me know. Appreciate it. Okay, so why is this only applied to one thing? I'm confused. Oh boy. That's the whole point. Okay, so this is literally a partial function. So we're trying to. Okay. I understand. So this is a partially applied first class type family. For boring math reasons. I like that. Okay, so what we're trying to do is in TS. Okay, so let's write some stuff. So find what's the function? Is it literally find index? I thought it was like find index of, but we can look real quick. I assume it's in here. Okay, so this is what we're emulating. That's what we're trying to get. Okay, so let's just put the type signature in there. That should be enough for me to understand it later. By the way, typing this stuff out just helps me now and later. So I think this code makes a lot more sense now. I think when the first time I looked at this, I was like blown away. But the fact that you just made me realize that tie equal is just partially applied helps a lot. Uh, technically it's key equal equal, right? Okay, and then so okay, then we gotta figure out what this stuck thing is. The stuck type family is one which can't reduce any further. Why do we use stuck and not just nothing? There must be a reason for that. Oh, okay. So if I see. So if how do I I want to go. I mean, we can just go look at the source code. That's the beauty of this whole thing, right? Oh, it doesn't. Okay. Why can't we just call it undefined? Is there something else? Is there a reason it's called stuck? Is this just like a historical thing, or I was expecting more here, but that's fine. Basically, that's the key here. So if you get stuck, how do you get unstuck? Like, does stuck mean like you're literally, if there are no instances? Okay, so when you get stuck, you raise, like, ultimately the runtime will lead to undefined because there's no type instance for what you're doing. Is that right? Not, oh, compile time. Right. That's the whole point. Sorry. So stuck behaves like a compile time undefined because they're so I like that. That's helpful as well. Right. Okay, I sort of remember that we couldn't do partially applied type families. That was part of the point of the first class families, right? Um. Okay. So is this or bottom kind because the compiler can't reduce the type family further, it will simply give up. Okay, that's really cool. Again, this code looked super foreign the first time I looked at it, but I feel a lot more confident about it now. Okay. Once you said partial, or well, you didn't. The way you worded it was perfect, essentially, for me. Okay. Da-da-da-da. Oh, interesting. So we could physically error if we wanted to. Is it T error or error? There's a type level error. What's the difference? Oh, one has a. Oh, they both have a message. So the only difference is one is text and one is string. Okay. Interesting. So this is really cool stuff. I can't wait until I get to a point where I can actually use it for a project. But I feel like I still need to learn a lot about Haskell before I can do that. Okay, let's break this thing down because this is pretty wild. All right, so this just makes T and TS available down here. Uh, this comes from no. Where does that one come from? Rankin types? Ah, right. Scope type. That makes sense. Shoot. I was hoping I could figure it out before chat told me, but I couldn't. You got me. I'm trying to like oh wait, it does? The scope type variables just makes so rank types enables the syntax, and then scope type variables just makes T and TS available, right? So I was close. I was just missing one important part. Ah, yes. Okay, cool. And also, I only do this once a week, so I really need to practice this kind of stuff. The this ampersand comes from type applications, and I think that's the only thing we're using. We might be using other things implicitly that I'm not super like. I just don't remember. I've not seen this before. Um, So this just produces an integer if it's a known natural number, I guess. And then we convert it to an integer. A type level natural number. Value level. Okay. Let me read this again. Type level natural number to value level. Because it's a proxy, right? The proxy doesn't contain any data. So we're taking the n. Okay. Good. Yeah, I get it. I think I get it. So now we have the term level integer, and then we convert it from integral. Okay. Yeah, I think I'm okay. The proxy doesn't actually contain any information. It's just giving you access to the type. And in this case, because we're evaluating the find element, we're either going to get stuck, which will cause a compiler error, or we're going to get a natural number. That's what member is for. And then that's proxied, and then we convert it to a term level, and then to an int. Neat. That's really cool. Is everyone okay? I want to check on everyone because I think this is pretty tricky. I think I get it. Typed Rat also thinks I get it, so that's very helpful. I think I missed a water reminder. Oh, we gotta test it. That's a good point. So I have a lot of help, to be fair. I like to think I'm kinda clever with this stuff, but I'm really probably not. But you're all helping me so much, so it's really you folks helping me. It's not just me. Although people have, I think Newmade has mentioned that he thinks that my brain works differently, which I suppose is probably helpful. Or something along those lines. Okay, so we have to test this. So we got to figure out how, because I don't actually know how. And I don't think it's even showed here. It's not, so that's fine. We'll figure it out. So let's do it. We'll leave this open. Okay, so we need to look at we need to evaluate with a type. Eh? I did. I don't know how. How do I? Because this is a constraint. I don't understand. How does... Oh, I get it. I get it. I'm not gonna look because I think you're gonna give me the answer, but I think I understand where this is going now. So we need to parameterize this as like what I had before, I guess. We'll just do it this way. I need T and TS. Wait. Is that... Okay. So I guess I'm confused. I was expecting to parameterize this with like a member. Or do I need to use find? I'm a little confused now. What is the relationship? I'm passing in T and TS. So okay, I'm giving it T and TS, and then it's building a member. Is that right? It's building a type level member. Yeah, I think I'm remembering this, but I'm a little confused about what's happening. So if I give it T and TS, it builds at compile time member TTS, and then why does member have to be here? Okay. So this is like a workaround in the type system. This isn't it's not like this isn't necessarily obvious. Is what I guess what I'm going for. So you need to give this a member such that this evaluation knows that we're producing a known NAT. It's a constraint that says you have to know what the index is. Have to know. And that's why it's wrapped in this known NAT. So what if we... Okay, I get it. I think I get it. So you're really just trying to evaluate this, but the only way you can do that is by making sure that GHC understands that you're going to get a known NAT back. I think I'm okay with this. Compile time. Okay. So anyway, okay. So the goal here is that we're evaluating this, but we need to help GHC realize that by evaluating this, we're going to get a known natural number back, and we use that, or we do that via this member helper type. Helper's probably good. So okay, neat. Okay, so do we need to write that in words? We need to write that in words. Oh yeah, it's a type alias. Okay. This is what's the difference between these two? Because this is not a type alias. This is uh, a type family. Type. What's the right term? Sorry, I'm starting to lose track of. Yes. Okay. This is a type family. This is just a wrapper. Okay. Let's write that. So this type wrapper is used to help GHC Okay, and then what happens if we give it a stuck? There it is. Yep, the kind. Okay, so the fact that it has the kind uh, um, annotation. That's the word we're looking for. That it's a type family and not just a type alias. Type alias. Let's use alias. Yeah. Oh, wait. Find LM is. I might be behind. This is a type family, right? This is a first class family. Oh. Wait. Um. So he's calling this a first class type family. Am I just confusing myself? Okay. Ay. Is an alias for a. I get it now. Okay. And the first class family in this case is a maybe, essentially. No, well, no, it's a natural. It's a nat. Makes them first class. That okay. Which are actual types. In this case, a natural number. There's a lot going on with this code, and I feel like it's pretty tricky. Okay, so I think that we are going to. Yes, it's very dense and quite difficult. I think it's one of those things where you just need to practice, right? Like right now we're doing some pretty interesting stuff, and the terminology is it gets really hard really quickly. Um, but this is sort of a trick that's necessary to produce a term level value from a type level value of reaching into a container and getting something out of it, right? In this case, the uh, you know the index of a type in a list of types. That's yeah. This is pretty wild stuff. I knew this was going to be tough. Um, but I think we're going to stop here. So just so we give you an idea, the next thing we're going to do is put things in and get things out and some other things. And then we're going to talk about open products. So these are still open sums. This is very hard. And I guess that's it. So open products, we're going to finish open sums, then do open products, and then discuss overloaded labels. So that's where we're at. Does anyone have any questions for now? Or are we okay with this? Oh. Machine call. Yeah, I'm not sure that I fully understand either. But let me explain what I kind of understand, I think. I'm getting there. So what we're doing is working on type level Haskell code. Do you have any experience with Haskell at all? That would help quite a bit. Oh wait, I can wait for you to. Okay, well that's gonna make it really really hard. So let me break it down a little differently for you. Okay, so if you're not familiar with Haskell, so essentially what we're trying to do is mimic a function that basically does this. So you have this function called findLm, and what it does is tries to find one in this list. So hopefully this is pretty readable, and it's going to pass back 0, 1, 2, 3, right? Because 1 is in the third space. What is it? Hang on. What? Oh, I think we're data list. We're shadowing. Sorry. Oh, is it called? I'm sorry. It's fine. No, it's not. I'm very. What did I just do? I thought it was called findLm. Give me a second. Sorry, machine call. I promise I will explain this. Just give me a moment. I gotta find the right name. No, I was doing this right the first time. I'm sorry. So it's we're trying to emulate this function. Okay, so this function, you give it a list, and it's going to look for something in that list. Okay, so it's trying to find an element that equals 1 in this case. So as soon as it finds a true, it's going to give back the index of that value. In this case, 0, or we could do it like this, and it will give back 1, right? Okay, so that's essentially the function we're trying to emulate. So what we do is we say, given a key, the k in this case is some value, and ts, which is a list of these k's. Try and apply that function. So we have find index, which is just to find. Oh, Google is amazing. It's the best part about Haskell, in my opinion, thus far. Like, it makes it so easy. So we're trying to find the index where key is. It's basically equals key, like this. So we're looking for the element that equals that value in TS, okay? And then we use a function, because this gives back a just something, which is like a value, an index, and we convert that from the maybe type to either the stuck type or the value that it actually is. So ideally, let me show the example of this running. Hopefully you're still with me. I'll feel silly if I'm talking to the rest of you who are following this already, or in theory following this. I need type applications and find lm at 2 at 1 2 3, and we also need data kinds. Okay, so we're finding the element that's 2 in here. But the weird thing about this... Oh, the point is that we're doing it at the type level. So all of this machinery here is actually happening at compile time. So this here is being compiled behind the scenes to give us this 1 at runtime, essentially. So this nat val function takes a value at compile, like, let me say this differently. This here is going to be evaluated at compile time. So when I write find lm at 2 at 1 2 3, it's going to evaluate that, and this is going to be basically proxy of the number 1. Okay, natval takes proxy 1 and brings it into the runtime at runtime or term level, and then we convert it from an integer to an int. That's basically what's happening. So what we're doing, this whole book that we're working on, which by the way is in front of me if that's not familiar, we are learning how to write code at the type level. This isn't for